Hi everyone, and welcome to our notes on 5-8. What we're doing in this lesson is we're solving radical equations. So we've done a lot of work with radicals here in the past few days, and it's been a lot of, in my opinion, difficult work. And so I hope that this lesson will be maybe a nice break as far as I think it's easier to understand. It's easier to solve equations than it is to simplify, in my opinion. So with this, I hope it'll be a fresh breath of air to you. A nice refreshment for a lesson that's simpler than maybe the past few days have been. So let's take a look at this first problem. What we're doing here is we're solving equations. So whenever we solve an equation, we're isolating a variable, solving for x, and the way we do that is we always take the inverse operation to solve, such as the inverse operation of adding is subtracting, multiplying is dividing. In this case, I want to get x minus 3 by itself. So I got to do the inverse operation of the cubed root, because I want to get rid of this cubed root sign. So in order to do that, I got to do the inverse operation. So what's the opposite of cube rooting something? Well, the opposite of cube rooting something is cubing it. In that way, this cancels out. The cubed root of something cubed just cancels, and you're just left with what's underneath the radical, which is x minus 3. An equation is a balance, so once you do what you do to one side, you must do to the other side. So if I cube the left, I need to cube the right to still make it equal. So as I cube the right, 3 cubed is the number 27. Now I simply solve for x by adding 3 to both sides, so x equals 30. And there's our answer. We have successfully solved for x. However, before you move on to the next one, it says check for extraneous roots. Class, what an extraneous root is, or an extraneous solution, that's also a term that we use for this. Extraneous means that you do everything mathematically correct, but you still get an answer that doesn't satisfy the equation, meaning that it doesn't work. And this happens. So normally when we solve equations, I give you the option. I say it'd be a good idea to check your work, but you don't have to if you don't want to. This lesson, I'm not giving you an option. You must check your work, because there are times where you can do everything mathematically correct and still get an answer that doesn't work. It's called an extraneous root. So you got to be careful of that. So on every single one of these, be sure to check your work. Doesn't take long. So as we check, we say, well, x is 30, so let's put that in for our x. It's the cubed root of x minus 3, so 30 minus 3, that equals 3. To check our work, we simplify now the left side. It's the cubed root of 30 minus 3, which is 27. That equals 3. So now I take what is the third root of 27. If you haven't memorized it yet, that's okay. You could easily just open your calculator. If I hadn't closed mine, if you do that in your calculator, the cubed root of 27 is 3. So 3 equals 3, it checks out. Now we know for certain this is our answer, and now we can move on to the next one. So let's try problem number 2. Problem number 2, it's the square root of x minus 8 plus 9 equals 8. So I want to get this part all by itself first, so let's take care of this 9. Subtract 9 from both sides, and now we have the square root of x minus 8. That equals the number 8 minus 9, which is a negative 1. Now I want to get x minus 8 all by itself, so I got to get rid of the square root. The opposite of square rooting something is squaring it. So there's our inverse operation, and now our square root cancels with our square, and we just get x minus 8. What you do to the left, you must also do to the right. So I square the right side. A negative 1 times a negative 1 is a positive 1. All right, finishing this one up, I add 8 to both sides, so I get the number x equals 9. This is my answer for problem number 2, but before I move on to problem number 3, let's check our work for extraneous roots. So as we check, it's going to be the square root of x minus 8, which we got the number to be 9 for x. So 9 minus 8 plus 9 equals 8. 9 minus 8 is 1, so now we get the square root of 1 plus 9 equals 8. The square root of 1 is 1, so 1 plus 9 equals 8, and we get 10 equals 8. What the world? 10 does not equal 8, so does this one check? Absolutely not. We, my friends, just got an extraneous root. So make sure that you are very clear in saying x equals 9 is not the answer. So cross it off and put extraneous root. That's what I want to see you do on your next chapter test. It's an extraneous solution or an extraneous root. What this one is saying, class, is there is no number that you can put in for this equation to make the left side equal the right side. There's an infinite number of numbers out there, and not one of them works to make the left side equal the right side. It is just impossible, so there is no solution. There's an extraneous root. Okay? No solution. As we look at problem number 3, I want you guys to practice this one by yourselves. Make sure you check your work. As you did this one, hopefully you got an extraneous root for this one as well. We're going to square both sides to get rid of my square root. So I get x plus 4 equals 36. Subtract 4, so x equals 32. As I check my work, I get 32 plus 4, the square root of that, equals a negative 6. So now I get the square root of 36 equals a negative 6. And then if I take the square root of 36, the square root of 36 is 6. Does 6 equal a negative 6? Absolutely not. So this, again, class, is an extraneous root. Cancel that off and put extraneous root or extraneous solution. Another thing I will accept on our next chapter test, if you want to, is there is no solution. So the empty set symbol there, that 0 with a slash through it, I would also accept that. If you didn't want to write extraneous root, you could just write that 0 with a slash through it, and that means that there's no solution. Make sure that you make that very clear to me. If you answer x equals 32, I'm going to think that you didn't know what you were doing on this problem. You just gave me an answer that does not satisfy our equation. So make sure that you make it very clear that that's not a root. You cancel it out, put extraneous root, or no solution. Last one, problem number 4. It looks kind of fishy, it kind of looks difficult, but it's a lot easier than what it may appear. I want to get rid of this square root sign. So the way you get rid of the square root is by squaring both sides. So I square root this, or I square that, and take a look at this. I also square the right side, and in that way, I got rid of this radical as well. So now both radicals are gone when you square both sides, so you just get 6x minus 4 equals 5x plus 2. Doesn't that look beautiful? After you square both sides, the radicals just are gone, and now you can simply solve your equation. Subtract 5x, add 4, and we get the number 1x equals 6. Here's our answer. Let's check for extraneous solutions. So I get this, 6x minus 4. So 6 times 6 minus 4. The square root of that equals the square root of 5 times 6 plus 2. Let's see if the left side equals the right side. 6 times 6 is 36, and 36 minus 4 is 32. So we get the square root of 32 on the left. On the right, we get 6 times 5, which is 30, and 30 plus 2 is 32. So on the left, we get square root 32. On the right, we get square root 32. So square root 32 equals square root 32. This checks out. Now our answer, we know, is x equals 6. So hopefully that was pretty basic. We solve equations by taking inverse operations on both sides. Once you get your solution, make sure you check your work.